So our next speaker is Halle Lambeau. And as she's coming up, Halle's working on her master's in integrated bioscience program at the University of Minnesota Duluth. She's interested in avian conservation research and has contributed to projects related to threatened and endangered species management with various federal agencies and nonprofit partnerships. And in particular, one that she and I have gotten to work on is with Kestrels, and that's what we're going to hear about from Halle today. So, Halle.
Clinton. Hi, everyone. Like Clinton said, my name is Halle Lambeau. I guess I should stand in front of the mic. And I'm a graduate student at the University of Minnesota Duluth in the Integrated Biosciences program. And I'm really excited to be here today to talk a little bit about my master's research. This is kind of half of my master's research here that I'm presenting today. And it is centered on factors influencing productivity at American kestrel nest boxes in the upper Midwest. So many of you probably know that kestrels are a widespread, common falcon species. You can kind of see here from this breeding bird survey data map that they're pretty much found throughout the United States as well as greater North America. They are also a secondary cavity nester, which means that they don't create their own holes to nest in. Rather, they use holes that are made by other species like woodpeckers or natural cavities that might be occurring. But they also readily adopt human-made nest boxes, which is good for us. It makes them really easy for us to study. They'll also sometimes nest in like your old barn or something like that too. So there are lots of folks out there using kestrel nest boxes for research, management, and conservation of these birds. If you look down here at this map, the American Kestrel Partnership, and each of these green dots indicates a number of nest boxes that are contributing to their larger data set. So it's really cool. It's become like a really big citizen science project for people all around the country and greater North America to help out in conserving these birds. If you don't know, American kestrel populations have been declining roughly since the 1960s, depending on where you look in their range. Again, this map is from breeding bird survey data, and you can see it's mostly orange and red with a little bit of yellow too, showing that they really are declining over a lot of their range, at least based on breeding bird survey data. And if you look here, where we are, also orange and red. So kestrels are also declining here. And they're actually listed as a species of greatest conservation need in Minnesota, in part because of these breeding bird survey declines. That map there on the left shows how their numbers have declined in these breeding bird survey routes in Minnesota specifically. And thankfully, there's kind of an abundance of kestrel research out there. Lots of people are studying these birds because lots of people are interested in why they might be declining. It's kind of enigmatic. We don't really know why. But a lot of that existing research is kind of centralized in the eastern United States and the western United States. So a lot of the papers that you read come out of New Jersey, Florida, Idaho, Utah. They've got some big programs. And a lot of these studies have produced kind of variable results, which in my mind validates the need for local and regional study on these birds. There's also a data gap of published breeding season research in this part of the country, so the central kind of Mississippi flyways area, which is kind of where my study comes in. I'm hoping to kind of fill that gap a little bit. Of the past research that does exist, we know that kestrels prefer open habitats with ample perches for nesting. They're very much a grassland bird species, but they do need perches to hunt. Past studies that have looked at kestrel nest box occupancy and factors relating to that have found a couple things. They found especially that the direction of the entry hole of the nest box, the patch size of the surrounding landscape, and the surrounding land cover are important for those nest boxes and if they're going to be occupied. One study, this is from 2023, so quite recent, found that developed land around the nest box actually decreased the likelihood that kestrels would nest there, whereas pasture and hay and cropland around nest boxes had the opposite effect, where it increased the likelihood that those nest boxes would be occupied. In terms of past research on nest success, again, the results are pretty variable across studies and regions, But some negative factors have been identified, one of those being European starling presence in and around nest boxes. If you look here, this is a photo from one of the nest boxes that I monitor that shows a starling nest. Unfortunately, they do really use the boxes if they're there. Also, proportion of cropland. So even though I just said that some studies have found that cropland can attract kestrels to nesting, some people also suggest that it might be serving as what we call an ecological trap, which, if you don't know, basically means it's an area that looks really attractive, but it might not have the resources, or it might be a stressful environment for those birds. Finally, clutch initiation date. So it's a pretty well documented phenomenon in lots of bird species that the later you nest, the kind of more likely your nest is going to fail. There's a number of reasons that could be, but that's well documented in kestrels as well. That brings me to my research question for my master's thesis, at least one of them, and that is, which factors are influencing nest box occupancy and success here in the upper Midwest, specifically Minnesota and Wisconsin? So to go about answering this question, I had a study area of about 7 nest box sites in eastern Minnesota and kind of all throughout Wisconsin. 6 of these sites had already been well established. They had nest boxes for a number of years. And myself, plus Frank Nicoletti from Hawk Ridge Bird Observatory, established a new site in Douglas County, Wisconsin, of 75 nest boxes, and we did that in 2022. So that gave me a sample size of 434 nest boxes to get data from in 2022, and we had a little bit less, 412 in 2023. And I also want to note that I only collected data from these top nest box programs. The rest was contributed by my awesome collaborators, some of which are here today, and this project wouldn't have been possible without them. In terms of data collection, so what we did is we monitored the nest boxes, right? In both 2022 and 2023. We aimed to monitor them about every 1 to 2 weeks, but depending on who was monitoring them, whether it's volunteers or myself or whoever, some boxes were checked more or less frequently. But we use a pole-mounted camera system to do this, and this is really cool because what it does is it reduces the stress that we're giving these nesting kestrels. So we just stick the pole in, take a quick video, take it back out, look at the video, see what's going on. We recorded a lot of things, occupancy, eggs, nestlings, and anything else that was of note. And we saw some really cool stuff. I mean, when you have 400 nest boxes, you're gonna see a wide range of stuff. So this picture on top I like to show because this is a 6-egg kestrel nest, which if you don't know, they typically lay 4 to 5 eggs, and 6 eggs is pretty great. And this is a nestling just hatching there. The photo on the bottom here shows a northern red-bellied snake that this kestrel adult caught for prey, which is pretty cool. They're eating reptiles this far north even. We also did ban the nestlings at ages roughly 11 to 30 days with an average of 20 days in there, but that's not particularly important for my talk today. Okay. So I had all this data, and so I needed to analyze it. And I performed statistical modeling using generalized linear models with a log-link function. And I modeled occupancy and success as binary variables, where 0 means a box was either unoccupied or unsuccessful, and 1 means that a box was occupied or the nest was successful. I also modeled another variable, which is egg hatching success, and I did that with an events trial syntax, basically meaning that I modeled it as a proportion of the number of hatched eggs divided by the number of total eggs. And I did that as another variable of nest success. In terms of my predictor variables, I included distance to nearest nest box, whether that box was occupied or unoccupied. I did that in order to try to get an idea if interest-specific competition was playing a role in nest box occupancy. There's also an extremely wide range of the distance between boxes in my study. So the minimum was 91.55 meters, and the maximum was about 40 kilometers between nest boxes. So huge range. The average was about 2 kilometers, though. I also did distance to nearest body of water. That's pond, lake, or river or stream. And the reason I did that is because there's really little data on kestrel preference with regard to water sources. There's some evidence that they prefer living closer to water, and that was just told to me in personal communication by one of my collaborators. And then, again, pretty wide range in distance to water from nest boxes. Continuing on with my predictor variables, I used MRLC NLCD 2021 land cover, and this is just land cover data in a GIS format, raster format, and what I did is I summarized the land cover at a 100 meter, 500 meter, 1 kilometer, and 2 kilometer buffer size around each nest box. And I was particularly interested in 4 land cover types that I thought would be important for kestrels. Those are developed land, pasture and hay, cropland, and natural open land. And then my final predictor variable for these models is clutch initiation date. Remember I said pretty well documented that later nests fail more often, but I wanted to see if that held true in my study area as well. And I defined clutch initiation date as the date the first egg is laid. Okay, so on to my results. So this is a lot of information, but a couple key points. Our occupancy rate for all the boxes averaged around 49%, which is pretty good. That's pretty on par with most large-scale nest box studies for kestrels. Our success rate was really high, about 86% of nests for overall success. And that's not unexpected for cavity nesting birds to have a high success rate, especially raptors. And kestrels, we're putting these boxes about 10 to 12 feet off the ground, so there's not too much that can really get to them and cause the nest to fail. So that's good that we saw such a high success rate. Egg hatching rate was lower at about 76%. And then we also collected data from about 1,500 total nestlings that we banded, which is pretty incredible. Okay, so I guess to explain this graph a little bit, this is showing occupancy and which factors were influencing it. Anything above that 0 line there indicates that that factor positively influenced occupancy in my study. Anything below the 0 line indicated that factor was negatively influencing occupancy. And anything that's a black dot was significant in my model. Anything with a white dot, not significant. So I found that greater proportions of pasture and hay and a greater distance from water both positively influenced occupancy in my study. And I found that more cropland and more developed land both negatively influenced occupancy in my study. Both natural open land and distance to boxes were insignificant, didn't matter. Moving on to nest success, the only variable that was significant for overall nest success in my study was clutch initiation date. And so just like other studies found, I found that there was a greater chance of nest failure later on in the breeding season. You can see it drops off pretty suddenly here. And it drops off kind of around May 5th. But important to note too that nests failed both before and after the May 5th date. So it's not like every nest before May 5th succeeded and vice versa. Okay, moving on to egg hatching proportion. So again, anything above the 0 line, positive, anything below the 0 line, negative. So I found that clutch initiation date, distance to water, and pasture hay all negatively influenced the egg hatching proportion in my study. That means that the later a nest was, the farther from water, and the more pasture and hay, the less eggs per clutch hatched. Whereas the more natural open land and the more cropland near boxes, the more eggs hatched. And developed land was insignificant in these models. Okay, so that was a lot of information, but to kind of summarize it, I've got more variable results, basically. So I did find that nests that begin later do have lower success and hatch fewer eggs per nest, so that's good. That tracks with what the literature says. But I found some pretty interesting contradictory effects of land cover. So I found that pasture and hay increases occupancy, but decreases egg hatching proportion. On the contrary, I found that cropland decreases occupancy, but increases egg hatching proportion. And then I found that a greater distance from water increases occupancy, but decreases egg hatching proportion. So, pretty confusing. But what this tells me is that kestrels are likely choosing boxes based on the surrounding land cover, And land cover, at least in some part, is influencing the ability of these kestrel adults to lay viable or hatchable eggs. We really don't know why these results are so contradictory. It could potentially be tied to prey abundance. Cropland has the potential to have some of these pest species that kestrels like to eat, things of like small mammals and invertebrates, so that could be part of it. But really, we think that further research is kind of necessary to entangle these relationships. But the important part is that my results do differ from those of similar studies, which again, like I said at the beginning, in my mind, supports the need for localized research on these birds. So previously, studies found that cropland increases occupancy and decreases nest success, but I found the opposite. Cropland decreased occupancy and increases egg hatching. And I had a pretty large sample size, so I think it'd be hard to say that my results are just due to random chance. And kind of a takeaway message I want to leave you with is if I'm finding that our birds are actually doing pretty well around cropland, I think that means that it is kind of in an idealized world, it would be prudent to collaborate with farmers and ranchers if we're trying to place nest boxes near cropland. There is a way to make cropland even more attractive to kestrels, and that's by leaving perch trees up or installing simple perches as well. And we've actually seen that kestrels can be pretty effective pest reduction for farmers as well. So this study here out of Michigan at a cherry orchard, if you look over here, the key point takeaway here is that they found that when they installed kestrel nest boxes, the number of pest birds, so the birds that were feeding on the cherries that they didn't want around, sharply declined when they installed kestrel nest boxes. So kestrels really can act as effective pest reduction. I think it's possible that we could form partnerships to kind of incentivize that. So there are lots of people I need to thank for this project, specifically Hawk Ridge and the MOU Savaloya grant, in addition to all these organizations, Saxon Bog too. And I have a million people to thank, but just to name a few, my advisor, Dr. Matt Ederson at the University of Minnesota, Duluth, Frank Nicoletti and Janelle Long from Hawk Ridge, all of my collaborators. So these are all people who contributed data to my nest boxes. Some of these people are here, Mark Martell, Kristen Hall. All these people I cannot thank enough because without their data, my project wouldn't have been possible. A number of people helped me by installing and constructing nest boxes, and I did a t-shirt fundraiser that was designed by Emma Renier, which you can't see at the bottom. But these are my references, and with that, I'm happy to take any questions you might have.
Yeah, I'm wondering if you have insights about the variable factors that influence nest initiation date, and if any phenology change associated with climate change is modifying that in any way.
Yeah, it's a really good question. So there's been some research that suggests that older adult kestrels, so adults that are not in their second year, so after second year birds, nest earlier. And that could be because they don't necessarily need to find a mate potentially, or maybe they already know the nest site that they want to settle in, or it could be other reasons as well. But there's also been study that shows that older birds tend to have higher nest success. So it could be a factor of older adults having better nest success and nesting earlier. But I unfortunately didn't take data from adults in my study, so I wasn't able to test that effect. But in hindsight, that would have been something good to see. So great question.
So with the opposite effect on occupancy and hatching success for the land cover variables, what would you tell people to manage for? Would you do manage for occupancy or do you manage for hatching
that's
success?
a great.
Or can you combine them?
Yeah, it's a really great question. It's super hard to know from just one study, but I think what this says is that, so a lot of people are saying that agricultural intensification could be contributing to the decline of American kestrels, and I think that's totally valid and probably at least in some part true. But in this part of the country, potentially there could be something that is mediating those effects. And so rather than managing for a specific land cover type, I think, kind of like I said at the end, just using existing land cover and installing boxes where we think kestrels would nest in, and then talking to landowners around those areas and trying to potentially de-incentivize them from using like pesticides and herbicides, and citing kestrels as pest reduction. So that would kind of be my best like management suggestion, but yeah, it's definitely confusing.
So a related question. So when you say cropland, are you talking primarily about corn, soybeans, or what kinds of crops?
Yeah, great question. The NLCD land cover data doesn't specify crop type, but in this area, yes, it's mostly corn and soybeans. And we did think about that, where corn obviously grows a little bit taller. Kestrels tend to prefer a little bit lower vegetation. So that could have been part of the reason why we saw lower occupancy with cropland as well, because we got a lot of corn around. It's a good question.
Thank you for your research. This is really interesting. I noticed on one of your early slides, it showed the decline of the population across most of the country, except for in the lower Mississippi River region. Those numbers, it was on an earlier slide, it looked like they were actually going up. Do you know what the cause or what the correlation is there?
Yeah, I think I'll go back to it because it is an important point. Yeah, so really great question. So it does look like they're potentially even increasing down here. And some of the theory or the hypothesis as to why that's happening is related to climate change. And potentially these birds, when they're migrating, they're not going as far north in the summer, or they're not going as far south in the fall. So that could be potentially kind of artificially increasing the numbers in some areas, while also potentially artificially decreasing the numbers in other areas. So that's kind of the biggest hypothesis right now as to why they could potentially be increasing in some of those more like southeast areas. Yeah, great question.
Do you have any data on causes of nest failures?
Not for my study specifically. I guess I do have anecdotal data, just not any like modeled data. And for causes of nest failure in our study area, most of the time it was either abandonment of nest for whatever reason. And when I say nest abandonment, that means that, you know, we check a nest box, it's got an adult, it's got eggs, and then we come back the next week and the eggs are there, but no adult, and then we keep coming back and the eggs just never hatch. We never see an adult again. And so it's really hard to know what happened in that case. Did the adult die and stop tending to the nest? But did both adults die? Because kestrel males also care for the nest. Or are the eggs not viable and the adults found that out and so they went to another nest site? So we don't really know what happened in that case. So nest abandonment happens. And then depredation does happen, where especially in my more southern sites, they get things like raccoons, squirrels, some other bird species depredating the nests. We get starlings kind of playing that role up here, weasels as well. So depredation does play a role too, but thankfully these boxes are high up enough that it's not an incredibly huge factor.
Back here. Another question I have is that a meadow vole can be a very important prey species for the kestrel, and they go through significant population fluctuations from year to year, and possibly some of those fluctuations you were seeing in productivity or nesting success might be explained by the availability of the meadow voles, which might be determined by perhaps scat analysis from the chicks in the nest or from the surveys of meadow voles in the vicinity of those nests.
Yeah, really good point about meadow voles and their importance as a prey species. Yeah, I didn't perform any like prey or scat analysis. I did look at prey remains, and I did some other stuff, but I was not conclusive enough to get that data that I needed for that. Unfortunately, too, in the United States, we don't have super great long-term small mammal data for a lot of species, and so it's kind of hard to track some of these long-term declines with some of those small mammal cycles. But I think you make a really great point that these are areas that are really ripe for research, especially looking at different prey species and their importance for kestrels. Thank you.
Halle, thank you so much. I mean, Beaver Creek Reserve collaborates, and we have a couple awesome sets of data that you've helped and you've looked at the variables for. Have you noticed a change from north to south, longitudinally, with your initiation dates and things like Badger Mine, which is a reclamation site where we have great success? Have you noticed that change in north to south?
Yeah, that's a really good question, asking a north to south gradient. And originally, I had been looking at if latitude was a good variable to measure some of these factors, occupancy and success, egg hatching. But it became a little bit too complicated because of the extreme differences in nest box sizes or nest box numbers between my sites. But again, I think that's a really good question, and I wish I had enough time to study that to see if like these clutch initiation dates are getting much earlier over time, and like where are we seeing those changes in the long term. Again, like an area I think is super ripe for research, and I wish I had enough time to look at that.
The next step for the successfully hatched nest is to fledge successfully and then have the brood success. Now, you did ban the birds. I was just wondering if you had any comment on, or is just more research needed on what the fledglings are doing and how well they're faring in relation to land use?
Yeah, great question. I did not look at any post-fledging success. There are lots of people looking at that now, though. It's kind of like the next big question mark for kestrels because we know that they're declining. We don't know why. And we think it probably has something to do with that kind of first year after they leave the nest. And there's something going on where they're not coming back necessarily to nest. So great question. Again, I didn't have time to look at some of these bigger factors, but there are lots of people studying it. So stay tuned, and there will be, I'm sure, lots of research coming out about that.
Thank you, Halle.
Thank you.